Alrighty, so now let's talk about our first two types of graphical displays for quantitative data, the dot plots and a stem and leaf plot. Now you might be familiar with these, but if not, all good. We're going to learn how to construct them as well as how to analyze them, otherwise known as describing the distribution. So both of these graphical displays, as you can see, since we're going to be making these by hand, they are typically best used for small data sets. Now, with these graphical displays, we can see individual observations or individual values in the data set. So in order to construct these graphical displays, we're going to need the following criteria to make sure that we do them correctly. So a dot plot, a title, so we'll need a number line, typically our scale. We'll plot the correct number of dots above the value on the x-axis. Of course, we got to include a title. And we're going to need to make sure that each dot is equal size and equally spaced out from one another. That way, like, you don't have one giant dot here at 9 and then one small dot at 0. They need to be equal size and equal distance so you can actually get a fair comparison. Now, for stem plots, you'll need a title, you'll need your stems and your leaves, and you're going to need a key. Now, the tens places are going to be the stems, and the leaves are going to be the units place. So the way I'd read this is 151, 154, 157, 159, starting now in the next group, 162, 163. Now, we have to have a key and a title, and one weird thing about this too is that there's going to be no commas here. We're just going to put the numbers next to one another. And if there is no observation for a particular stem, you're going to leave the leaves blank. You're just never going to eliminate stems, meaning that if there would have been no values in the 170s here, I would have still put the 17 in the scale, but I would have left this area blank. Now, when given a graphical display, we tend to describe what is easiest to see from that display. So we're going to use the CUS model, center, unusual, shape, and spread. But because we're describing what we can see and the quartiles aren't exactly the easiest to see from these two graphical displays, we're going to stick with finding the median, the middle, and the range, the max minus the min. And if we are given the summary statistics, then we'll follow the rules to use based on the shape. Again, if it's symmetric, we'll use the mean and the standard deviation, whereas if it's skewed, we'll use the median and the IQR. So, Mr. Pinto collected the following data from his Unit 1 test for his AP Statistics students in fall 2019. Let's construct a dot plot and stem plot of the data, then we're going to describe the distribution. So here are the test scores. Don't worry, it was graded on a curve. And it also wasn't out of 100 points, so it's going to be all right. So let's count how many observations we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So here n is going to equal 17. So my title here will be test scores. So I'll indicate my title. And then I'm also going to need one here for my stem plot. So test scores. And we'll make this T chart here. And we're going to need a key. So my key will just be off to the side here, and it's just going to say that 5-4 equals 54 points. But let's start with the dot plot, because that'll be easier to convert that to a stem plot. And the dot plot is the most basic type of graph. So it's usually a pretty good starting point, because from there you can form the histogram, the box plot, or the stem and leaf plot. So I'm going to draw a line here, which will be for my test scores. And I need to create a scale. So I'm just going to do, let's see, my lowest observation looks at about here at 42. And my greatest observation is at about 57. So I need a scale that's going to accommodate this. So I'll start here at 42, 44, 46, 48, 50, I almost forgot how to count, 52, 54, 56, 58, 6, oh, nope, I don't need that, boom. Okay, so here's what we're going to do now. We are going to put these points on the graph here. So one at 54. Okay, one here at 45. Notice they are equal distance. One here at 52. One here at 57. Another one here at 52. One here at 46. One here at 42. Oh, two more at 46. one at 50, another one at 45, one more here at 53, actually our first one there at 53, another one here at 45, one here at 44, another one at 50, one more at 54, and then one last one here at 45. All right, so looking here, you can see that I've placed a dot at the number of times that that observation has occurred. So here at 54, I have 2 students who scored a 54. Here at 45, I had 4 students who scored a 45, and etc. So what I'm going to do here is, it's only in the 40s and 50s, so the problem is if I just did 4 and 5, I'm going to have 2 giant peaks. So what happens sometimes in a stem and leaf plot is you actually need to split your stems up. So for example, what that's going to look like is, for here, this interval is going to have 40 through 44. This next one will have 45 through 49. This one will have 50 through 54, and this one will have 55 through 59. And now from my dot plot, I can just convert over. So here's 42, and then here's 44. And it looks like that's going to be all of it there, so I'm going to stop the stems there. And then here in the 40s, I've got 45, 45, and I'm trying to keep these as equally spaced out as I can. 46, 6, and 6. Oh, devil. And then in the 50s, I have 50, 50, 52, 52, 53, 54, 54, and then the last one here at 57. So we can kind of see, it looks a little bit more symmetric in the dot plot, but then, or here, it also looks kind of symmetric. You can kind of say it's a little skewed to the right. So it's up to you. Either one is fine. Our wiggle word is going to be there appears to be. It appears something. And that's how we kind of get away with things in AP Stats, is this idea of this approximately or appears to be. That is our wiggle room, and then they won't be able to take off credit because we didn't say it is, we just said it kind of looks like. All right, so we need to find our summary statistics now. These are the graphs. So the range, we know, is max minus min. So 57 minus 42 is going to give me a range of 15 points. The median is going to occur at n plus 1, so 18 over 2. The median is 9, but 9 isn't one of the score values. And you would be correct in saying, wait, Mr. Pinto, it's not 9, it's at the 9th observation. So I'm going to count here at the 9th observation. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my median here is actually going to be 46 points. And I noticed that it looks like there's a gap in between the 47 through 49 range. So I'm going to just note the gap right here. And then another gap between 55 and 56. All right, so we're going to take all of these sentences now, and we're going to describe our distribution. So we're going to use complete sentences now because this little scratch work here, it's not going to get the job done. We are statisticians. We are communicating what these values are. So the first important thing when describing a distribution is to give context. So the distribution of test scores has a median of 46 points and a range of 15 points. The distribution of test scores appears approximately symmetric. And we're not going to doubt ourselves, or we're not going to say approximately symmetric and skewed right. Nah, it's got to be one or the other. So based on the stem plot, it looks a little bit more symmetric. Although from the dot plot, I'd argue it's a little bit more skewed right. So I'm just going to say the distribution of test scores appears approximately symmetric, and I'll just add a note from the stem plot. And then lastly, anything unusual? Well, there are a few gaps in test scores between, or at 43 points, between 47 and 49 points, and again between, and again at 55 through 56 points. So we've described the distribution here, and we've given it context. So I need to make sure that I got full credit for my answer. So did I address a measure of center? Yes, I gave a median. Did I talk about anything unusual? Well, yes, I listed the gaps. Did I call this a specific shape? Yes, I called it approximately symmetric. And did I give a measure of spread, whether that was the IQR or the range? Yep, I talked about the range. And most importantly, did I give it some context? Yeah, I'm talking about the distribution of test scores. So this is going to be a complete, full response, full credit response that we would accept on the AP exam. So what I'm going to need you to do now is to pause the video. And lucky for you, I've already crafted these graphs for you. But what I need you to do is I need you to look at this video. Look at these problems and pause the video. Take your notes and try out the practice problems. Then in what's going to feel like about 5 seconds, we're going to go over the problems together. So go ahead and pause the video and try out the problems for yourself. Alrighty, so hopefully not too challenging, but here we were asked to describe the data for commute times of 24 randomly selected New Yorkers. So the distribution of commute times has an approximate median time of 22.5. I did this because 24 plus 1 is 25. 25 divided by 2 is 12.5. So I can't have a 12.5 observation, but 12.5 is in between 12 and 13. So that falls in between these two values here. So the average there would be 22.5 minutes. The range would be the max of 40 minus the min of 5. So that's 35 minutes. The distribution of commute times appears approximately symmetric and uniform. And there appears to be gaps in between each of the 5-minute intervals, right? So a gap in between 6 and 9, 11 and 14, etc. So I have my context, my center, my unusual, my spread, and my shape. And then here we're asked what proportion of New Yorkers have a commute time less than the average commute. Well, if I were to add all of these observations up and divide by 24, it turns out my average is also 22.5, which, think about it, makes sense since this distribution is approximately symmetric. The mean and the median should be relatively close. So the proportion of data less than the average, well, I count here these 12 observations out of 24 observations. It's going to be 50%, right? That relative frequency we talked way back in categorical data. So about 50% of New Yorkers have a commute time less than the average commute time. Cool beans, not too difficult. Some examples of questions they might ask you with dot plots. Now, let's take a look at a stem plot here, and these are for scores earned on an Algebra 2 quiz. One thing I'm always going to do is I always take data from the math classes that I teach and I write problems about them, so who knows, you could end up as a problem one day. But here we have 11 observations, and if we turn our stem plot, it's going to look like it's skewed to the left. So if I were to tilt my head or I guess tilt it this way and read the stem plot, it looks skewed to the left there. So let's use our IQR rule to find any outliers. So I find an IQR of 12 points using the lower fence of 54 points and an upper fence of 102 points. I find that this score here of 45 points would be considered a lower outlier since this value is less than the lower fence value of 54 points. Now, if I were to remove that value, what would I expect to happen? Because think about the tails. The mean, the overall trend, gets pulled towards those extreme values. So if right now, if I'm skewed to the left, my average would be lower than what it would be if I removed that value. So let's assume I removed that 45. I could recalculate everything, and you'll notice that my average is actually going to increase. And that's because now that we've removed the low score, the overall trend is no longer being pulled towards that lower value. And when we do that, actually, if I tilt my head again this way, now my distribution looks slightly skewed right. So you can see there's just different variations of questions they can ask you about dot plots and stem plots, but the important thing is to be able to construct the graph and describe the graph. Then from there, in our discussion in lesson 1.4 about summary statistics, you can also determine if there's outliers, what proportion of data meets a certain qualification, and what some of the relationships are that exist throughout the data. So that is going to conclude our discussion there on dot plots and stem plots. Stay tuned to learn more about histograms.